Okay, welcome back. On page 292, they finally get around to saying, okay, this is all kind of mildly interesting, but what's it got to do with me? And so they talk about this example here where you're using the find view by ID to inflate a control. So you're creating the control now. You are creating something on the heap and pointing that thing over to something on the stack. Now, let me give you a slightly better example of why understanding this is important. Okay, let me just go make me a loop here. Okay, I'll tell you what, I'm just going to do it right here. I'm going to say, I don't know, for int index equals 0, index is less than 100, and index plus plus. Okay, I just got a for loop here. Okay, so let's just say I wanted to do this thing. Actually, let's make it, instead of making it 100, let's just make it 10. That'll be a lot easier to do. Okay, so I'm going to go in here and let me add something in here. I don't know what. I'll tell you what. Ooh. Okay, let's just keep going. I'm going to make a random number. So random r is equal to new random. Okay. This is something you should have remembered from the previous classes. And so I'm going to go in here and say junk, the first element in junk, okay? The very first element in junk is going to equal to some random number between, I don't know, between 1 and 100, which should be 101 if you remember how that works. Okay, cool. So I'm going to display that out. So let's display what the index is. Then I want what junk sub 0 is. Okay. Let's just run this to make sure I didn't make any mistakes. Okay, this looks pretty decent. So index goes from 0 to 9. I've got some random numbers thrown in there. Okay, cool. Now this is not a very efficient way to do what we just did. Let me explain why. Okay. When I created this thing, that means every loop, it's going to create me a brand new age, a brand new first name, a brand new junk, a brand new random, and then it's going to put a random number in there and display that. So every single time, it's going to create these 10,000 integers over and over and over and over. And to tell you the truth, that's not necessary. Can you see what I'm talking about? How in the world could I make this more efficient? I can make it more efficient by not including an awful lot of this stuff inside the loop. Let's move all of this up. Okay, now do you see what's going on? So instead of the age being built 10 times, and first name being built 10 times, and 10,000 integers being built 10 times, and random being built 10 times, they're only being built one time now. So now it's going to look the same, right? When I run the application, it's not going to be any difference, as you can see. It's going to run exactly the same as it did before, except this is more efficient. So do you understand why it's efficient? Because I'm not creating these things over and over and over again. I'm only doing it one time, and then this loop only includes those things that are important to be in the loop. Okay? Now, so these things go into scope one time, and then these things, get used, and then finally, not here, But at 37 is when these 4 things fall out of scope. Okay, now I'm going to do another one, and just to show you how confusing things could get, I'm going to do a recursive routine. So I'm going to say public void, I don't know, recursive. And so then I'm going to start off roughly the same. I'm going to say, you know, int age is equal to 12. And I'll tell you what, let me just copy. I'll copy this stuff. Okay, but when I get down to here, I'm going to call this guy again. A second time. I'm going to make him a recursive call. Okay? Which means age, string, and int will never fall out of scope. Okay? In other words, once this thing runs, it's going to get down to here and then call itself a second time. And so these things will never, ever fall out of scope. And if I run this thing forever, it's clearly going to break, right? I mean, wouldn't you kind of sort of think that? So I tell you what, let's put a sleep in here. So I'm going to tell it to sleep for 100 milliseconds, which is 1/10 of a second. There's 2 different types of sleep here. So I'm going to hit the Alt-Enter and go for qualify and do that one. Okay, so what this is going to do, this is going to put some stuff on the stack, not much. Put some stuff on the heap, quite a lot. Sleep for 1/10 of a second and then start over again and again and again, and nothing will ever go out of scope. Okay, so this time when we run this guy, I'm going to launch this thing called a profiler. All right, so the profiler is this really cool thing that allows you to see what's going on. All right, so I'm going to run my guy. Okay, now watch this. I'm going to click on the memory guy just to bring him up. Oh, I forgot to actually make the recursive do something. Can I stop and start over? Okay, let me go back. Daggone it. Hey, it helps if you're going to do one of these things, you would... In fact, I'm just going to comment this guy out temporarily and do recursive. Okay, so now when this thing fires up, it's going to immediately start building these 3 items and then calling itself and building these 3 items over and over and over and over. So let's get the profiler. Let's get the new guy up and running. Come on, Mr. Profiler, keep up. We got things to do. Okay, now I'm going to click on this guy, and you should be able to see that because this thing is recursive, the stack, which is this part up here, really isn't being impacted by this much. I mean, really, you know, that's the stack right there, this little thin green line. It's not really being affected, but the heap, which is the bottom part, where it says Java, so this is the stack, this tiny little sliver, and this is the heap, because none of the objects could, in other words, even if we had garbage collection here, it wouldn't do anything because there's nothing to collect. You told the garbage collector to go find all the unused objects. Well, there aren't any, so this would not do any good at all. Okay? So, this would eventually run out of heap. Is it going to run out of stack? No. Probably never, ever run out of the stack. But these things never fall out of scope because they get called over and over and over. Is this beginning to make sense? So when you're doing something recursive, you kind of sort of need to know, yes, I'm chewing up memory, and I need to know that. Okay. So let's do yet another one. Okay, this time I'm gonna go ahead and wire a button. So let me go back to my guy here and grab a button, and I'm gonna grab a button. I'm gonna put him between, okay? And I'm getting ready to have, I tell you what, let's go ahead and just let's do 3 buttons, since we're going to need 3 of them in just a minute. Okay. So give me a second to go through and change the attributes for these things, because I'm just going to call them button top, middle, and bottom. Okay, I've created these buttons. I've changed their attributes to be in top and be in middle and all that. And back over here, I've created my instances. Now, why did I build them at that level, at that indentation level? Because I wanted them to have larger scope so I could talk to them later. Here's where I inflated those guys. Okay, that kind of makes sense. Okay, cool. Now I'm going to build me an event handler to handle this kind of thing. So I'm going to go back to my guy the way we've been doing it in the past. I'm going to grab the attribute for the top guy and scroll on down here to where it talks about the on click. Now remember, I can make up any method name I want. In fact, I'm going to create the method name first. So I'm going to go down to here, and this could be practically anything. It doesn't have to be named anything special. So I'm going to say public somebody clicked on the top button. I mean, it can be, really ridiculous. As long as the argument is a view. Ooh, I forgot to put the return type. Void. Dang it, helps you to spell void correctly. Okay, and of course it's never heard of a view before. Alright, so now, let's go back to this guy. And on click, and somebody clicked on the top button. Alright. Now, going back to here, let's say that I want to build an array. And then every time you click on this thing, I just want to build the array a little bit larger and a little bit larger and a little bit larger. This is just kind of a crazy exercise, but just bear with me for a minute. So I don't really know. So let me think about this a second. Okay, I'm going to need another variable here. I'm going to need a variable called size. Okay, so integer. How about array size? And let's start off with array size being 100. Okay, so down here I'm going to create me an array. So an array, I'm going to go ahead and just call it junk again, is equal to new int of array size. Oh, come on, what did I call it? Oh, ha ha ha. I didn't put it in the right scope. I meant to put it way up here. Okay. Phew. Okay. And so, just like before, I'm going to have to do something with it. Let's just fill it full of random numbers. I'm gonna grab this. And I'm not necessarily following the best practices things I was telling you about before. Except now this is going to be array size. Okay. And this is going to be index. Cool. And I'm not going to display all of them. That would be way too much junk showing in the screen. So I'm just going to have it display like the first one, just to keep the clutter down. Alright, so all I'm going to do is just say et display append, and I'm going to say index 0 is equal to, and then 0. Okay. Now, if I do this now, and it's going to just build this array, fill it full of random numbers, and display out the current version. But of course, we're coming up on the 15-minute mark.